Alright, so we're back. Today's tomorrow. The UPS guy came and brought me some goodies. Our little power supply and some T-nuts that are, I got a different brand on Amazon. They were a tiny bit more expensive. I thought they'd be a little bit better. They are significantly worse. So they will still work, but it's not going to be ideal. Fortunately, I don't need that many of them. And then our other magnet arrived. So while we waited, I drilled and tapped 2 holes in here. Let me zoom out. There we go. Alright, so I drilled and tapped 2 holes here for the DIN rail. So let's get that mounted, get the power supply in. Right, and this guy will want the line end to be on this side, I guess, because the power is going to come in right through here. So these are pretty cool. They've got the little snap thing here. You can just pop them on. They lock in place. Alright, so we got that. Now we need to get power up to, well, we got power for the fan here. That's easy enough. And actually, let's just do that now, because this has also 2 terminals for positive and 2 for negative. What is this? Well, that's neat. Looks like there is a relay that activates when it's got the right voltage out, DC OK. So it looks like if you were monitoring it, you could tell whether the power supply was good or not and running. That's neat. We won't use it. Alright, so let's see. So I wanted you to kind of be tucked through there. It's about right here. Now this is actually a 4 wire fan. And I don't know which wire is which. Oh, 3 wire fan. Let me just see if I can't find that real quick. Sensor's yellow, red is 12, and black is ground. Fair enough. So we won't need yellow. And I brought down my little ferrules. Let's use those. This is another kit I just got off Amazon, like everything else. It's not as nice as the proper ones, but you know, they're a very small fraction of the price. And you just put all your wires in here and crimp this down, and that way you don't have to worry about any stray wires getting in the way or getting in between 2 terminals. Alright, so positive, I guess we'll put these 2 together. Alright, so it seems the memory card had filled up and the camera shut off. So while that transferred, I did a little bit of wiring harness work, just so you wouldn't have to watch me put all this stuff together, and did a little cable routing and some planning. So what we've got is our, you see that alright? Alright, so we've got our power coming in here, we've got ground, neutral, and live, or neutral and live. I don't have enough room in here to do terminal blocks, and I need 2 lives and 2 neutrals for this and this. These 2 in the center here, I'm not sure what those are, but they're not for power. They're linked together somehow. So you only get 1 neutral and 1 live. So I just put 2 wires in a terminal here, and I'm using there we go. I'm using these earth terminal blocks. It's kind of dual purpose. They clamp down onto the DIN rail, and the I guess it gives a path for the earth from the terminal down into the DIN rail, which is then attached to the whole body. So that's a good convenient way of getting earth points without having to drill and tap holes and get ring terminals and all that stuff. And because they clamp down onto the DIN rail to make a good connection, they also are a good way of making a little end stop. So I've got earth there, live and neutral, get those wired up here. I already did the harness that comes with the power supply. I mean, there's really not a whole lot going on here. It's just they both get live and neutral, and then everything gets earthed down to these blocks. So I didn't think you'd be missing too much. But it took a good 20 minutes for the memory card to transfer and me to do all this stuff. So I also found out if you're using these extrusions and you've got components right up against the walls, you can actually route cables in the channel there, and they kind of get held in place. So that's nice, keeps things a little more organized. Alright, so this guy and this guy both go down here. I think I'm gonna have to put this side on, at least 1 bolt of this side, so everything reaches. Let's get that in there. Alright, so we should just have our 2 earths, this one and this one. We need to go down the terminal blocks here, and we should be good to go as far as power goes. Just to make sure. Yep, that's good. Okay, so then this, I was kind of imagining would go back here, and it looks like it fits. This is a little messier than I'd like right here, but what are you going to do? You can't have it be perfect and still expect to get the sides and everything off. Alright, so we should be good there. Let's actually power it up and see what happens. Probably a good idea before we put anything expensive on it. Just have to unplug my garage door opener here for an outlet. Fortunately I have, or unfortunately I have very short ceilings. Fortunately, or unfortunately, I'm very tall so I can reach it. Hey, look at that. Power off. Yep, so that works. So that means there's a fuse in there too. So that's nice. I'll get the meter back. Double check that these guys are the right polarity. Otherwise you will fry your motors. Negative, positive, 75.5 volts. That's good. Over here, you got a voltage adjustment on this too. I'll put a link to this power supply down in the comments. It's or down in the description. It's a Meanwell from Amazon, which I hope means it's actually a Meanwell and not a ripoff. But it was, I think, like $25 for a 12 volt 1.5 amp with adjustable voltage and this little switch here to. Actually, let's test that out. Well, let's do the voltage first since I'm already on here. 12.11, 12.08. So if we wanted to be really precise, we want our voltage I can maybe see that. If we want our voltage to be actually 12 volts, you can turn this little potentiometer down. Oop, 8, 9. Good enough. Now let's see what this switch is all about. So I guess this should be closed now. We should hear the beep. Alright, and if I turn off the power, hey, look at that. Turn this back on here once this guy's not lit up anymore, although I guess maybe it doesn't matter. Yeah, so that's pretty cool. You can monitor your voltage that way. And let's keep going. We've got our Arduino mount over here. This goes on this side. I guess I can reach that all right. Really, this probably should have gone in first, but that's okay. I'm just going to make up a quick cable here. I've got a bunch of, I use my power adapters for various things, and I save the ends when I cut them off. And this one fits the Arduino. I'm going to use that just because it's going to be, I think, a lot easier, especially long term. Well, hopefully I won't need to be back in this again, but it'd be easier than soldering in. Plus, I don't really have any wire that fits those holes very well. So okey doke. So we can get the Arduino mounted. I can plug this in here in a minute. This goes this way. Eek. All right. So that is in there now. Whew. So this goes to the motor. So we don't need to worry about that yet. This guy, let's get a. Yeah, we'll just leave it here for right now. Power. Barrel jack. You know, this I think I'll just wire tie to the rest of this. Should be right about here. Couple more of these things. I'll put a link to this kit down below if you do a lot of wiring like this. It seems to be, you know, pretty reliable. Works well. You know, it's not the multi-$100 one that the pros would use, but I think it was like, I don't remember what it was, but it was pretty cheap for the whole kit. There we go. Alright. Screwdriver. Smaller screwdriver. Bigger screwdriver. Here. Negative. Positive. All right, we should be able to at least turn it on now and see what happens. Get this turned around here. There's our power. Let's see. Hey, it's right side up. Huh, that's awesome. All right, so now let's set the motor on here. Now I'll get the front panel on a little bit better. Actually, I need to put the top ring around here. I took it off so I could drill and tap the holes for that power supply. Again, these extrusions are all still pretty loose because I want to get everything lined up before I really tighten stuff down. Probably take this off of drill mode now. Okay. I'm thinking again. We actually want to get the top part on first before I put the panels on, I think. So here's our top plate with the motor. And now it doesn't matter which way around this goes, but I have this connection here. Oh, I am going to have to cut up the other cable. Where did I put that? There it is. Power supply end and motor end, so I will have to really cut it right about here. That should be more than enough room. Let's get our soldering iron back on. Lighter. This one got pre-shrunk a little bit from the heat of soldering coming up the wire, so I got to cut that back. Alright, so this goes in here. Either one of these, doesn't matter. I guess this one because it's closer. So those will plug into the motor. A few more gigantic cable ties to take care of this. All right. It's upside down. Jeez. All right. It will just barely work. All right. So that is in there. Stay. All right. We need to do the top ring, but the top ring needs to be attached to the motor first, and then that whole bit gets set down inside. So let me swap things around a little bit. We gotta put the magnets on here. Move this up here. Go get the magnets. We'll do one at a time. Feels safe. And yes, this does look terrible, but the important part is it's flat. 1, 2, 1, 2, 1, 2, 1, 2. I don't remember if I already mentioned I did put a set screw in the collar here up against the motor shaft. Oh yeah, no, you stay here. So I probably, so that's fine. That's it's not fine. So I probably want, look, free energy. Ow! I'm probably gonna want, do I want all of the polarities the same way? That is a good question. I'm gonna consult that YouTube video that first got me thinking about this and pointed out where to get the magnets, such that the polarities topside alternate north-south, north-south. Sounds good to me, and that's the way I've already accidentally got it. So this one is negative, so I want, well, so I want this one to be this way. Because if this is north, this is south, north and north cancel out. It's north, south, north. So I want the opposite side, the one that attracts, to be up. Look at that, no broken magnets. Alright, so this ring is back on. This, get these sides out of the way. This needs its ring. Oop, this needs its ring put on first. Looks like I do have enough room there. Yeah, because once this needs to attach from this side. This would probably be a good time to use these terrible ones. Wait, are these the terrible? I don't know. You know, I wonder, can I use this other magnet to suck one of these up against the top? The answer so far is yes, but I want something that's not going to try to grab onto the magnet. Good thing I went with the stainless steel screws. Hey, it works. Actually, it works pretty nicely just for getting these things aligned. Come back here. We'll just come back when I'm done. Alright, that was an ordeal. Let's try to get this flush all the way around. Certainly feels like it is. We can tighten these down. Alright. That is our top. Is that right? This is all sandwiched together. And then that sits on top of there. And the sides hold this to the bottom. I'm pretty sure that's right. Alright, so let's find out which way our motor is going to go. Set this down here for a moment. It's looking like this side over here will be where I want to have my motor connections. Although technically, really, the front has the most room of all the sides without running into anything. So I guess I'll put the connections on the front, facing the front. Let's get our data connection plugged in. Power. And I guess I can still cable manage it a little bit from the sides. Well, really, as long as they're not hitting the fan, there's nothing else in the way, really. So I think we're good there. All right, so now let's put the top, well, let's fire it up real quick to make sure. Let's get the front, no, we'll just put the panels on. It seemed to be fine, but we need to get something connected so we're not dealing with multiple pieces of stuff. All right, let me zoom out here a little bit. There we go. Okay, so we need to get T-nuts in here. Going to use the decent ones for this, I think. Actually, try a trick here. Take a marker, put a mark on the extrusion where each one needs to go. That'll save me some time lining them up. Especially since this really isn't, this front panel doesn't really come off here very well. So I can't just set it to the side. Should be nice and even with the top. Alright, well, with it all together now, let's plug this guy back in. Neutral, black, ground. Okay, let's just give this a quick run here. Make sure the motor works and all that before we put all the sides on. Oh, it did a thing. What? Did I have the panel upside down when I did the... I think I had I must have been holding the panel upside down when I said, hey, we got it in right the first way around. Alright, well, that'll have to come back up. Fortunately, it's not that bad of a fix to take that off and flip it around. Let's see first off if the motor works. So it's set to 300. That's odd. Why would you do that and be weird? Why are you acting strange, motor? Oh wait, I feel like... if we turn you up? Say 1,000. Yeah, it's... Because I remember when it was on the desk, it definitely felt like it was ka-chunk, ka-chunk, ka-chunking around. And it's probably amplified quite a bit now that it's got a platter and some weight and stuff on it. I guess we need to run the first thing we should do is run the Clearpath software and let it auto-tune. That might be it. It might just be a little freaked out that it hasn't, you know, figured out what it's in yet and how to behave. So I'm going to take the front panel off and flip the screen around, and then I will get us over to the computer and get the motor plugged in, and we'll run through the auto tuning and see what that comes up with. Okay, so we're up in the office. I've got the machine set over there on the floor. I've got this USB plugged in, and I've got the software started up here. It automatically found the motor. So the first thing we need to do, since we haven't done auto tuning yet, and I'm hoping that's what the jerkiness is all about. Let's do setup, tuning, auto tune. I've read and understand. Next. All right, sure. Next. Max velocity, 1,000 RPM. I think 3,000 is what we had. Well, you'll get best results by using a velocity as close as possible to the default setting. I'm guessing that's this. So let's just hit next and see what happens. Unlimited rotation. Shaft rotates freely in both directions. All right, let's see what happens. And I have done this before. This will take a little while. Oh, I do probably need to hit run. All right, now let's see what happens. Did a thing. All right. So we just click next here. Disable. Next. And finish. All right. So let's get this thing back down into the shop and we'll get it all put back together. Alright, so we got it back together. I saved you the trouble of having to watch me put all the side panels back on. I put the handles on. As you can see, that wasn't really too exciting. Just got a handle on each side so I can pick it up. As people were asking, the back is vented. So, actually there's a good amount of air coming out of there. So yeah, that's how the air is getting out since it's all sealed up. But before we get to the to the tumbling part, I have a question I need to answer for myself. And I've been thinking about this for a lot, well, probably since I started the idea of building this thing, would be what would happen, since this is a spinning magnetic field, if we put a coil of wire on top. We should get electricity, shouldn't we? My only question is, with the alternating north and south magnetic fields, I don't know if that will cancel it out or what will happen. But we're going to find out. Where's my meter? Alright, so we're going to want volts DC. Unless that magnetic field thing is going to be an issue. Our range, it's an auto range. Let's try 200 RPM. There's something, although this flashing, maybe it is AC. Huh. .23 volts at 1500 RPM. .45 volts. Well, that's a little less exciting than I was hoping for. But it works. That's the important part. And there's probably a way to do this that I'm not aware of that would be a whole lot more efficient. But alright, I just wanted to check. Alright, so let's I've got a couple buckets here. I've got a smaller bucket and a bigger bucket. Let me move the camera so you can look down in there. Alright, now you're up on the top. We'll put these in the little bucket. I've got my stainless steel pins that I bought to use in the regular tumbler. They didn't work out very well, so I've been saving them until I could get this thing built. Well, that's neat. That on its own is neat. And that is a surprising amount of force. I mean, that's just a few. That's probably 4 or 5 ounces, maybe at most. Well, that's super cool. That's too many, I feel like. Let's turn this down to as low as I can get it to start out with. 59 RPM. Ooh. That's definitely too many, though. Hold on, I'm going to switch you to 60 frames per second. Which, yeah, means I guess it'll have to be a 1080p video. That is really cool. I wonder why they seem to spread out like that. Okay, okay. And maybe about all we want to use. Let's turn this on and see what happens. You know, the one thing I'm noticing is this is a very strong attraction between there, and the bucket doesn't seem to want to move at all. So I may not even need to put that ring on here, although I may still do it because it looks cool. And I've already bought the stuff and I've already machined the little pillars in the corners, but I don't think it needs anything to hold on to it, keep it from falling off the edge. Alright, let's turn it up and see what happens. You know, this feels like a safety glasses moment. Okay. Interesting. That was 500 RPM. It doesn't hurt or anything. It just feels, you know, I don't know what it feels like. You know, it feels about the same as if you were to just drop them on your hand. So let's go. Well, I'm just going to crank it up. I don't want them to all fly out of here, so we'll just ramp up slowly until it looks like they're trying to escape the bucket. Okay, that's a little more aggressive. I've noticed the bucket is starting to move a tiny bit, so I guess we will need that ring, or at least it'll be a good idea. With the increased RPM, you could definitely feel it a little bit more, but it still wasn't, you know, anything near painful. It still just kind of feels like they're raining down on you. So that was what, 1,000 RPM. Doesn't look like we're actually going to be able to go much faster without the lid on, because I did notice one or two already has escaped, but let's go up and see how far we can get. Oh yeah, the other thing, this is not quiet. I was kind of expecting, you know, if you got like a vibratory tumbler, if you use one for reloading or anything else, just the standard like Harbor Freight ones, I would say this is notably louder than one of those already. Oh, in fact, I've got a decibel meter. One moment, please. Alright, got our decibel meter here. I'll just, so you can see, I'll just read it to you. There's no good way to get it in the frame at the same time. Let's start with, let's see, what C weighting is what people normally use, isn't it? A or C. Response, fast. Let's start at 100 decibels. I will set this right here so I can see it. And this is about 4 feet away. So start at 1,000 RPM. So that's 83 decibels. Let's see if for comparison, I've got the air compressor over here. Let's see what that runs at about the same distance away. Alright, so that's really only about 72 decibels. So this is already quite a bit louder than a you know, standard 55-gallon-ish drum compressor. So let's see how far it goes. Jeez. Yeah, it gets up to about 90 decibels. And that was at 2000 RPM. Things were starting to come out. It doesn't seem to make a whole lot of difference. Like the jump from 1000 to 2000 wasn't really that drastic, I don't think. So probably not. Well, we'll try 3000 real quick and see. Actually, I'm going to put on earmuffs here because that's getting really pretty annoying. Alright, we'll see if I get all the way up to 3000 or if these things really start to escape. Yeah, that was 3000. And they were just starting to get out of there. So yeah, it seems to work. I kind of want to run tuning on the motor again with the bucket on there. I had no idea it would be that much. And you can see just moving the bucket around, it's enough to get the motor moving. Camera cut out again. The motion recording was canceled due to the writing limitations of the SD card. And that's a class 10 card. I'm only doing 1080p, although it's 60 frames a second, but I think that's what keeps happening to my videos, why it just seems to stop recording from time to time. I guess it's time for a new card, but recording in 4K or 60 frames per second, that's going to be at least a 128 gigabyte card. And I'm not sure what's beyond class 10. But for now, I guess there's nothing really to do but see how it goes. Not with that. Ooh, I did want to see what happens foolishly if you try to put in small pieces of something magnetic. Now, are those gonna do anything or what? Seems very interesting that they kind of go around slowly. Now this is more of a polishing machine rather than a, I mean, I call it a deburrer. It probably will deburr as well, but these types are really meant more for, you know, you can kind of see that, you could see like that gentle scrubbing action of all these little guys up against here. That's going to make your parts magnetic, it seems, if you use steel. Can't tell if those are a little magnetic or if it's just this stuff obviously is magnetic now. I kind of wonder, because you can see all those little, it's almost like the bolts are getting attacked by tiny little bacteria all up in there wiggling against it trying to digest it. Maybe less. First, see what happens if we do less. Interesting. So, I mean, nothing terrible's happened when I put magnetic stuff in there. Whether it, because it kind of seems to stick to the bottom. I don't know if that'll be effective, but it doesn't look like, you know, it looks like you can do it and it's fine. So it'll be interesting to see how that works out for magnetic parts. I do want to try one more thing here. What do just the bolts do? It almost seems like they're so heavy and the magnetic field is moving around so quickly that they don't get thrown around like the little ones do. They just kind of, you know, the one magnetic field will push it and then the other one will pull it back a little bit and push it and pull it. Interesting. So yeah, on the low speed, that's what's happening. On the low speeds, the magnetic field will get a big enough bite on one of these to really chuck it around. I almost wonder if you couldn't do magnetic parts with standard media. Like, it seems like it might be too violent for ceramic. So yeah, I'll just have to do some playing around with, I guess. If you got any ideas, let me know. In the meantime, I think I'm going to put this back in here. Maybe that much. Toss in some titanium keycaps, which is what this machine is built for. Maybe the rest of that. And let it run for a little while, see what happens. I'm thinking I may have to somehow buy or build a bucket that's got a cone in the center so that stuff doesn't get, or just glue something into the middle, so that stuff doesn't get trapped in the no magnetic field middle part. But I think these are supposed to generally have some sort of stuff in there as well. Add a little soap and water. Now this is probably really going to make a mess.